Hello all. From the previous classes, we have learned the structure of mux and its types. So in this class, we will see how to implement the Boolean functions using mux. So the first type is Boolean expression having n variables can be implemented with 2 power n to 1 multiplexer. That means if the Boolean function have n variables, for example, in the below example, you can see the Boolean expression f is the function of a, b, c. There are 3 variables. So in these 3 variables, the selection line is 3. So the variables and the selection line both are equal, means that is type 1. Look at this diagram. So we have A, B, C. There are 3 variables. The same way in the block diagram, all the 3 variables are selected as a selection inputs. Then the min terms 2, 3, 6, 7. So these min terms are connected with logic 1 and logic 0. So 2, 3, 6. 2 is connected with 1. 3 that is also connected with 1. 6 that is also connected with 1. 7 that is also connected with 1. So all the min terms mentioned in the problem all are connected with logic 1. So what about the remaining terms, that is 0, 1, 4, 5. So these all are connected with the ground. So that is the first type. So listen well, in type 1 all the variables, if n variable presented means all these n variable is selected for a selection inputs. The min terms only connected with logic 1 and logic 0. Next we will see type 2. So in this, Boolean expression having n variables can be implemented with 2 power n minus 1 to 1 multiplexer. That means, for example, the Boolean function is has 3 variables, means we are not selecting 3 as a selection inputs. We will take only 2 variables in the selection inputs. The remaining what we left is taken in the input side. So for example, that variable taken for the input is achieved by the implementation diagram. So look at this implementation diagram. For example, D0, D1, D2, D3. There are 4 inputs, means this is the 4 cross 1 mux. So we know for the 4 cross 1 mux, we need 2 selection inputs. So only one variable is considered for the selection. The another variable, for example, A and B are the variable, means B is taken for the selection input, but the left out A variable is considered as the one of the input. So we have D0, D1, D2, D3 as the input, A also the one type of input. So how we achieved the input expression means by the implementation of the diagram. So look at the diagram. So D0, D1, D2, D3. So we have 4 inputs. So for the 4 inputs, we have 8 min terms. So 0 to 7. So in this 0 to 7, under the D3, 3 and 7 both are circled. If both are circled in the row with respect to A bar and A, means it is taken the value 1. If none of the min term is selected, means there is the value 0 is considered. If any one is circled, means the circled min term with respect to the variable. Here one is circled, the respective variable is A bar. For 4, the respective variable is A. So that is given for the input lines. So D0 value is A, we have derived. D1 value is A bar, D2 value is 0 and D3 value is 1. So this is in this way we can compute the input values for the D0, 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 D1, D2 and D3. So let's get into the one example problem. So the function is it has A, B, C, three variables. The minterms mentioned here are 0, 2, 5, 6. So we can implement this by using 8 cross 1 mux because there are three variables. So 2 power 3 is to 1 mux is to be considered. So 8 is to 1 mux will be considered. But we can implement using 4 is to 1 mux also. So in general we will use 8 is to 1, but instead of 8 is to 1 we can do with 4 is to 1 mux implementation. So that is why the selection line is equal to the variable, means that is first type, but this is type 2, that is the selection variables are three variables but the selection line is only 2. So for 4 is to 1 multiplexer there should be two selection lines only. So for the two selection lines we can choose B and C. Out of these three variables we are choosing only B and C as the selection line. Only B and C as the selection line. So what we missed? Variable A is missed here. So this variable A is taken as the input of the mux. So for to implement to find out the value of A, we need the implementation table. So we have 8 inputs, 3 selection lines, but instead of 3 selections line we are only using 2 selection lines, but we have 8 inputs. So all these 8 inputs are given in this implementation table D0, D1, D2, D3. So then we have to circle the minterms mentioned from the formula. So 0, 2, 5, 6. Circle the minterms 0, 2, 5, 6. After circled, we have to derive the equation for A. So under the D0 only the circled expression is A bar. Under D1 it is A. Under D2 both the values are circled, so it is 1. Under D3 no one is circled, so the value is 0. If no one is circled 0, all the values are circled means 1. If any one is circled means with respect to the row assigned. So here for the 0 A bar is assigned, for the 5 A is assigned. So next, we have derived the expressions for D0, D1, D2, D3. How we implemented in the logic circuit. So, as we already said, this is 4 is to 1 mux. So, we need only 2 selection lines. So, out of 3 variables, B and C only considered here. And the lefted variable is taken as one of the inputs. So here for the D0 we have derived what is the value A bar. For D1 we have derived as A. For D2 we have derived as 1. For D3 we have derived as 0. So from the previous table we have derived the inputs for D0, D1, D2, D3. So we are implementing 8 inputs with 4 inputs. Even though we are having 8 inputs, the 8 is to 1 mux is derived with 4 is to 1 mux. Okay, so this is the logic diagram. One more example. If the problem has 4 variables, what we have to do? So the mux here have 4 variables A, B, C and D. and the minterms are 0, 1, 5, 6, 8, 10, 12, 15. So for the 4 variables, 2 power 4 is equal to 16. Instead of 16 into 1 multiplexer, we have used 8:1 multiplexer. So the type 2 is, I once again remind, the type 2 is, even though n variable is present, the selection line for the mux is less than the variable. So for 8:1 mux, we only need 3 selection lines. So even though 4 variables, we only use 3 selection lines. So B and C, B, C and D are taken for the selection lines. A will be goes to the input. So for the 8 inputs, the implementation table is look like this. So even though the function 4 variable, so 4 variable means how many combinations we will have? 16 combinations we will have. For the 4 variable means 2 power 4 is equal to 16. So from 0 to 15 we have 16 inputs. So all these 16 inputs are implemented by 8:1 mux. So what we need is only the 8 input D0, D1, D2, D3, D4, D5, D6 and D7. So how we convert this 16 inputs into 8 inputs means by this implementation table. So consider the first row is A bar and the second row is A. As you already know, we have to circle the minterms given from the formula. So 0 is circled, 1, 5, 6, 8, 10, 12, 15. All these are circled. Then next we have to derive the input for each data. So for the D0, both the minterms are circled. So the value is 1. For D1, only one value is circled, that is respect to the A bar. So it is A bar. For the D2, the 10 is circled. So with respect to 10, the value is A. So the A is the derived input for D2. So D3, no one is circled. So the value is 0. So for the D4, 12 is circled. The respective equation is A. For D5, 5 is circled. So the respective value is A bar. So for D6, 6 is circled. So the respective value is A bar. So D7, 15 is circled. The respective value is A. So we have derived all the inputs equation. So D0 value is 1, D1 value is A bar, D2 value is A, D3 value is 0, D4 value is A, D5 value is A bar, D6 value is A bar, D7 value is A. Next we have to do the logic circuit implementation. So we have 8 inputs. So for 8 inputs we need 3 selection lines. So 8 cross 1 mux. So for the 8 cross 1 mux we need 3 selection lines. So the 3 selection lines are B, C, D. So what we missed is the A variable. So the A variable is implemented here. So based on the expression we have derived. For the D0 the value is 1. For the D1 the value is A bar here. For the value D2 is A. For D3 is grounded. D4 is A. D5 is A bar here. D6 is also A bar here. D7 is 1. So in this way we can implement n variable by using 2 power n minus 1 into 1 mux. Okay, then the third type. A logic function is derived from the given multiplexer. Here we have the logic diagram, but we didn't know the Boolean function for this block diagram. So we have to derive the logic function from the circuit. So look at this diagram. So this is 4 cross 1 mux. Here the selection line B, C, but the one of the variable is taken here as a input. So the select variables are A, B, C. So three variables are presented in the Boolean functions. So next we have to select these D0, D1, D2, D3 by the combinations of B and C. We already know. So for the B and C, we will have four combinations: 0, 0, 0, 1, 1, 0, 1, 1. So out of four combination, we will select D0, D1, D2, D3 respectively. So that is given here as a truth table. So here the B and C value is 0, 0, 0, 1, 1, 0, 1, 1. So when 0, 0, A is selected. When 0, 1, A is selected. 1, 0 means 0 is selected. 1, 1 means A bar is selected. This is we get it from this diagram. So for both D0 and D1, A is selected. Then D2 is 0. D3 is A bar. This is given in this truth table. So let's do the expression. For D0 the value is 0. For B it is 0. So the expression must be B bar. C is also 0. So the expression must be C bar. So the F is A. So that is taken directly. So F is the function of A B bar, that is here it is 0, that is why here it is B bar. Here it is 0, that is why here it is mentioned as C bar. So both the combinations are same. The next is A, B is only bar here, C value is 1. So the next term is A, B bar and C, that is mentioned here. Next 0. We will not write the expression for this combination because the output is 0. Next one is A bar. So that A bar, B and C both are 1. So A bar, B, C. So A bar. The expression for all these three terms are grouped here. So F is equal to A B bar C bar plus A B bar C plus A bar B C. So after getting this expression, we have to simplify this expression. So by simplified, so here A B bar is common in both the terms. So we take it outside. So C bar plus C is inside. So what is the result for C plus C bar? If we consider C is equal to 0, C bar value will become 1. So 1 plus 0, 1. Or else C value is equal to 1, then C bar will goes to 0. So 0 plus 1 also means 1. So whatever the value C taken, the output is 1. So 1 into A B bar is equal to A B bar plus here A bar B C. So this is the final expression. F is equal to A B bar plus A bar B C. Thank you.